So in this lesson, we are going to continue reviewing for the chapter test. Part 2 of the chapter test will start out with a few system word problems. Our first one here is the sum of two numbers is 31. The larger number is 2 less than twice the smaller number. What are the two numbers? So what you're going to do is you're going to write down two equations. X plus y equals 31 indicates that their sum is 31. The larger number, so we'll just call that y, is 2 less than twice the smaller number. So then you are just going to solve it. I would use substitution. We know that y is equal to 2x minus 2. So let's go ahead and plug that in there. So we get that x plus our y value, 2x minus 2, equals 31. And so then it's just an equation that needs solved. So I would combine our x's, which gives us 3x minus 2 equals 31. Add 2 to both sides, so 3x is 33. And then if you divide it by 3, you get x is 11. Now I want to know what both numbers are. So remember, y is going to be 2 times that x value minus 2. So that's just going to be 22 minus 2, or 20. So the smaller number is 11, the larger number is 20. Then you can check if you add the two numbers, you should get 31. If you double the smaller one and take off 2, you should get the larger one, which is exactly what happened. Now, the second type of word problem is more of a monetary thing. It says Mary spent $52 on 2 adult tickets and 2 kid tickets to the movie. The next time she spent $50 on 1 adult ticket and 3 kid tickets. How much is the cost of an adult and a kid ticket? Okay, so let's call X the adult tickets and Y the kid ticket. So we technically have two equations here. We have the 2 of the adult tickets and 2 of the kid tickets, total up to $52. That's our first sentence. Now our second sentence says that 1 adult tickets and 3 kid tickets is a total of $50. So that is our equations that match. Now it is up to you what you decide to do. I decided to multiply this by -2. So my first equation, I'm just going to write that again. 2x plus 2y equals 52. In my second equation, I'm going to multiply every single piece by -2. And I'm going to get -2x minus 6y equals -100. And then I'm going to add the two together. Now what that will do is that will make the x's be eliminated from my equation. So I get -4y equals -48. So y is 12. So remember, that is the kid tickets. Now they wanted to also know the adult ticket, so we need an equation with x in it. You can use either one. I like that this is just a plain old x. It's going to make it, just nicer to solve. So I know x plus 3 times the y value I found. Now remember, that was 12, equals 50. Now 3 times 12 is 36. So we just have to subtract 36 from each side, and that is 14. So 14 is the price of an adult ticket. Okay, so that is a system that has to do with pricing. I kind of scoot you out just so you can see it. So here are some equations to solve. The first type of equation is a quadratic, and x squared equals a number equation. Remember, to get rid of a square, you want to put on a square root on the other side, but don't forget you need that plus or minus in front. Now, 18, since 18 is 9 times 2, you want to think of that as that 9 and 2, and I want you to simplify these as much as possible. So the answer would be plus or minus 3 radical 2. I can take the square root of the 9, but the 2 is left behind because it is not a perfect square. The second one, we have two factors that equal 0. So when it is factored like this, we're going to set each factor equal to 0. And then you get to solve them each individually. So we get x equals negative 4. Let me write that a little nicer so you can see it. And then we get x equals positive 3. Now our second one here, that does say minus 2x plus 5. It is not a factorable quantity, so let's apply our quadratic formula. So our quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a's. So our a is 1, our b is negative 2, our c is 5. Let's put that into our formula. So we get the opposite of b, plus or minus the square root of. Now b squared is negative 2 squared. So remember, when you do negative 2 squared, it is that entire quantity squared. That is going to become a positive. So that's a 4. So that's why I'll do that part in my head. And then the next piece is negative 4 times a times c. So you can do that in your head as well. Negative 4 times positive 1 times positive 5 is going to be a minus 20. So we're going to subtract 20 all over 2a's. Now a was 1, so just double it. So we get 2 plus or minus the square root of negative 16 over 2. Now in this particular one, 16 is a perfect square. I needs to be rewritten as, or I'm sorry, negative 1 needs to be rewritten as an I. So we get a final answer, well, almost final answer, 2 plus or minus 4i divided by 2. And since all of those pieces, the first term on top and second, are divisible by 2, you might as well divide by 2. And so it makes sure to divide this into both pieces. And we get 1 plus 2 or minus 2i. 1 plus or minus 2i. Now for a square, you're going to notice that plus or minus. For one like D, we are going to be squaring both sides. So there isn't a plus or minus there. Just make sure when you start out, this should be a positive number. We can't solve this if it's a negative number, but it's a positive, so keep going. So this is just going to be x minus 1. The square root comes off, and then 3 squared is just 9. And now it's a simple equation. Add 1 to both sides. The answer is 10. Now a similar thing is going to happen for E. To get rid of that 1/3, we need to cube both sides, or take each side to the power of 3 or 3 over 1, which will make those powers cancel out. That's what we want. So we get w plus 1 equals negative 3 times negative 3 times negative 3, or negative 27. And then just subtract 1 from both sides, and we get that w equals negative 28. Okay. And then let's move on to some absolute values. Make sure that your absolute value is by itself and it equals a positive number. If it equals a negative number, you gotta stop, but that equals a positive. So that's where we're going to have the two cases. We're going to say the inside could equal 4, or it could be the opposite case, that x plus 2 equaled negative 4. And then it's just a simple, just solve. So if we subtract 2 from both sides here, we get 2. If we subtract 2 from both sides here, we get negative 6. So the problem with G is this 2 here. So you have to move that first, get the absolute value of x minus 1 equals 3 by subtracting 2 from both sides before you do anything else, okay? So you have to do that first. So when you do that, now we set up the two cases. So we could say x minus 1 equals 3, or x minus 1 equals negative 3. And now you just solve. So if I add 3 to both sides, I get 4. If I add, I did the right math, but I didn't say it right. I need to add 1 to both sides, which will give me 4. And if I add 1 to both sides here, I get negative 2. So we get 2 answers for that. So most of the time, you're going to get 2 answers for any sort of absolute value equation, okay? So now we are moving on to inequalities. And some of these are a little fuzzy, and I'll tell you what that means. That was x plus 8 is greater than 3x plus 2. On the test, you'll be able to see that a little better. Now, we're going to go ahead and solve this, and we're going to go ahead and solve this by getting the x's to one side and the numbers to the other. So let's subtract 2x from both sides, and that will move our x's to the left. So then we should move the 8 to move the numbers to the right. So if we subtract 8, we get negative x is greater than negative 6. Now remember, in our next step, we are going to be flipping that symbol right there. So because of that, I'm going to highlight it, or you might want to circle it to remember to flip it the next time. So we get x is less than positive 6. Because if I divide through by negative 1, the negative 6 becomes a positive 6. Now I want the inequality drawn, and then I want the interval. So just pick a spot and put on 6. Put on something right below it and something right above it. Now our answer was, and I'm going to write over here, you can see it, is x is less than 6. And you see how this symbol mimics that arrow. And so let's put an open circle at the 6 and shade to the left. Less than left, that arrow should match. Now the interval should follow the number line. So the leftmost spot is negative infinity. The rightmost spot is 6. I can't stand on 6, so I put it in a parenthesis. So there's our first inequality. Let's do it again, just so you can see that better. That says 2 plus x is less than or equal to 5 plus 2x. So let's subtract x from both sides. That'll move our x's to the right. And then let's subtract 5 from both sides. When we do that, we get that -3 is less than or equal to x. And we need to turn that so that our x comes to the left. And so then we can follow it on the number line. So x is greater than or equal to -3. So put -3 at a spot on the number line. Show me something below it. Show me something above it. Because this is an equal to, color it in. Greater than, shade to the right. So what's our interval? Well, our interval should include a bracket on the -3, meaning I'm allowed to be equal to that value, and then I'm going to shade to infinity. I'm going to go to infinity. So that is a second inequality. Now let's do our next one. Let me tell you what that says. That says x plus 1 is greater than or equal to 6, or x plus 2 is less than 4. So let's start with each piece. Now when you have an or, we are going to solve each piece individually, see what the heck happens. So the first one, subtract 1 from both sides. We get x is greater than or equal to 5. The second one, subtract 2 from both sides. We get x is less than 2. Now we're going to put 2 and 5 on our number line. If you want to put any other numbers, feel free to do that. It's not a bad idea. X is less than 2 would be an open circle, shade to the left. X is greater than or equal to 5, closed circle at 5, shade to the right. You'll notice we have two unique things shaded. So because of that, let's go ahead and remember you're going to have to draw or write out 2 intervals. So our first interval, follow the number line from left to right, starts at -infinity, stops at 2. Now I'm not allowed to stand there, so I put a parenthesis. Now the union just means I have a second piece, because it can be the first piece or the second piece. And so it's going to be 5. I'm allowed to stand there, so I put it in a bracket, and I can keep going to infinity. So there is our third inequality. And then the last type of inequality that will be on the test is one like D. Let me tell you what that says just so you can see it. That's going to be 3 is less than or equal to x minus 2, which is less than or equal to 4. Okay. Now, this is a compound inequality. We want to get x by itself in the center location. So to do that, I would add 2 to all the pieces. And when I do that, I get 5 is less than or equal to x, which is less than or equal to 6. Now it's solved when x is by itself in the middle. We're going to go ahead on the number line, and in least to greatest order, we're going to put 5. We're going to put 6. Now, for this to be a true, correct inequality, you should see less thans in both locations. But look what the alligator is eating. I know that's silly, but it does help. Here, x is bigger than 5, but here, 6 is bigger than x. So that's why x is between 5 and 6. So x is stuck between 5 and 6. So, you know, technically, x is bigger than 5, but less than 6. So it's actually anything in between. That's what's great when x is in the middle of 5 and 6. Now the ends will line up with any equalities we see there. And so then just shade it in. And the interval is really nice for this one too. We started at 5, we ended at 6. We can stand at both locations, so we have an equal to at both locations. We have a bracket, okay? So that is what part 2 of your test is going to look like. I hope that helps you with that material. Please study by trying it again on your own. Okay, there you go.